afternoon, ladies and gentlemen. My name is Dr. John Belkowitz. I hope you're having an awesome day. We're here to talk to you about concrete dams and what we worry about the most when we're building these concrete dams. And I actually did a wonderful, long discussion with David this morning about it. We went to a lot of depth and detail, but I wanted to just overview that to give you a quick bird's eye view so you can get into that longer video, which was like 13 minutes long, a little bit later on when you have more time in your day. So when it comes to concrete dams, the first thing, and it's not just the dams, the infrastructures, the spillways, the hydroelectric equipment, there's a lot of concrete that's being placed over this localized area to support holding back water as well as generating electricity. Now, one of the things that we have to be concerned with is that we're putting in a lot of concrete. And when you put in a lot of concrete, it's kind of hard to replace it. More importantly, it's expensive to replace it. So what we want to do is be very selective with the type of concrete that we're putting in to deal with the following factors. The harshest and hardest thing that we normally see on concrete is either the physical attack or the chemical attack. And the physical attack can be broken into a few different things. One, it's that thermal shock that we're going to see, or the cracking that comes from the change in the heat generation of that concrete. If we pour that concrete too big, put too much cement in it, and don't have a good cooling mechanism, we can see that thermal shock and that thermal cracking. When they built the Hoover Dam, they had to do it in this beautiful checkerboard-like fashion and then put cooling pipes through it to control the heat. And if they had poured in one monolithic pour, it was going to crack, and then it was going to lead to a temperature generation that was going to take decades, if not hundreds of years, to cool down. So that's one thing that we're looking at, is to get away from that physical attack from thermal cracking. The other thing is water abrasion or cavitation. There's a lot of water movement. There's water movement and debris, and we normally call that turbidity, and that's going to attack not only at the surface, but the subsurface and eventually the body of the concrete. Now this we're going to see more in the water flow areas, not really up against the dam, but where we see water coming out of the dam, we might see some cavitation where we see our water bubble collapse and really destroy that concrete. So it's important for us to take this into account, as well as other things for physical attack. But the other piece of it is this chemical attack. And one of the worst things that we see in concrete is alkali silica reactivity. There's a lot of dams here in the Midwest that we've done samples on. When I say we, I mean the Bureau of Reclamation, other government agencies, or other types of private industry who have gone into older dams or even new dams, done cores and analyzed those cores, and found that that aggregate or the area around that aggregate has swelled excessively because of this alkali silica reactivity. And we need technologies that can meet the demand not only of construction, getting these technologies easier into the ready-mix operation or in retrofit, but also meet the demand of these physical and chemical attack mechanisms to make that concrete stronger and last longer. During these video series, we've talked about using colloidal-silica hydrogels versus crystalline pore blocking technologies. And while both have places in the industry, we've really gone over how the colloidal-silica hydrogels are better suited for this type of aggressive environment. So, hope you learned something today. Let us know if you got any concrete questions, concrete concerns. Don't forget to like, subscribe, ding the bell. Go concrete! Beat asphalt!